Hello students, welcome back to our physics class. Today we are going to discuss a small topic related to our SHM. Okay, so what is SHM? Simple harmonic motion, and how a motion is represented considering its displacement or velocity or acceleration and other quantities. Okay, so today we are going to discuss about the graph related to the position, that means the displacement, the velocity and the acceleration of a particle in SHM. And for one complete oscillation, for one complete motion time period, what about the graph? Okay, so in order to understand that, we have taken a simple pendulum. And the simple pendulum, when it is at mean position, x is equal to 0. When it begins to move towards right, x displacement increases, and on reaching the right extreme end, the displacement becomes maximum from the mean position, and that maximum displacement is called as the amplitude. Okay, now when it moves towards again to the mean position, the displacement decreases, and when it reaches the mean position, x becomes 0. And when it moves towards the left extreme end, what happens? The displacement increases, isn't it? Okay. And at the left extreme end, the displacement becomes maximum and it becomes minus a. Okay. Returning back to the mean position, what happens? The displacement decreases and becomes 0. Okay, so this is about the displacement. So what will be the graph? For one complete oscillation, when the body starts from its mean position, the displacement becomes, yes, we have to discuss, x is 0 at mean position, x increases as we move towards the right, then it becomes 0 again at the mean position. Towards the left side, it increases in opposite direction, becomes maximum minus a, and then towards the mean position it becomes 0. Okay, so this will be the graph for displacement and graph, isn't it? That means, what is the shape of the graph? It is a wave-like graph, and such a graph is called as the sinusoidal graph, isn't it? Okay, good. Now, what about the velocity? The equation, the general equation for velocity of a particle in SHM is v is equal to omega root of a square minus x square. So putting the value of x at each positions, mean extreme end, right extreme end, again mean left extreme end, and towards the mean. Okay, for one complete oscillation, the value of v becomes a omega at mean position. Why? X is 0, then root a square becomes a itself, then v is equal to a omega. Towards right extreme end, x becomes minus a. So what happens? Yes, tell me what happens? At right extreme end, x becomes minus a, x square becomes minus a square, that is a square itself, and velocity becomes omega root of a square minus a square, which is equal to 0. Okay. Similarly, at the left extreme end also, x is minus a square means a square itself, and velocity becomes 0. So what about the graph starting from the mean position? At mean position, velocity is maximum. At mean position, v is maximum, a omega. Now, moving towards the right extreme end, it decreases, becomes 0. Again back to the mean position, but in the opposite direction, it moves towards the negative axis, minus a omega. You have to write here minus a omega. Then towards the left extreme end, it becomes 0. There, it becomes 0, the third portion. And then towards the mean position, again increases and becomes maximum. Okay, clear? Now too, the graph is a wave-like graph. Now, what about acceleration? The general equation for acceleration is minus omega square x. So putting again the values of x at the 4 positions, we will get acceleration. X 0 at mean position, acceleration 0. X is maximum at the right extreme end, minus omega square e. Again, x is equal to 0 at mean position, e is equal to 0. X is equal to minus a at left extreme end. Where is the left extreme end? Yes, here. So minus a, then a becomes omega minus omega square of minus a. It becomes plus omega square a. Okay, plotting the graph. Mean position acceleration 0. Mean position acceleration 0. Right extreme end, it is minus. That means negative side. Negative axis minus omega square a. Again, towards the mean position, a is 0. A is 0. Then towards the left extreme end, here, okay, towards the left extreme end is maximum plus omega square a, positive axis, and again at the mean position it is 0. Okay, so these are the graphs related to the displacement, position displacement, velocity, and acceleration of a particle in SHM. Clear?